Attention, attention! Hello, everyone. Hello, Charmilen, Salvadora. Hello, Samuel. How are you guys doing? If possible, please type here for me on a scale from 0 to 10. How is my audio? Mainly, how is my audio? And also tell me if you are ready for our conversation about Lean Six Sigma, this fascinating topic related to problem solving, yeah? Related to operational excellence, related to analyzing, investigating problems that we don't know the root cause, right? I am doing all my best to touch base at least on a weekly basis with you guys, so I can answer as many questions as possible. Okay? Hello, Catherine. Hello, Marcelo. Hello, Jessica. It's a pleasure to be here with you. Today, I would like to start our conversation with a question that we got from Vindra. Vindra is by far one of the most engaged students in the history of MF Treinamentos, you know. And in fact, I'm gonna expand his question a little bit. He was asking about the 1.5 sigma shift, sigma level. Let's just remember that it's by far one of the most important capability indexes used in measure phase, in improve phase, control phase, right? So, hi Vindra, how are you? And then I'm gonna expand this. I'll be talking about the 1.5 sigma shift, but also I think it's a good idea to talk about Six Sigma. Like, what is Six Sigma and what is the performance associated to a Six Sigma process? Should we expect 1% of rejects? Should we of defective items? Should we expect 5%? Should we expect 0.1%? Should we expect 3.4 ppm? Should we expect 2 parts per billion? You know? So how do you guys see this idea? Let's talk about like Six Sigma, yeah? And then obviously I'll need today to open up my mini tab and then we'll explore from here. Okay, so I hope you guys can see my screen. Yeah, I hope you guys can see my screen. And the very first conversation that I want to have is, let me generate some random data here. 100 data points, C1, 10. Yeah, so I have just generated here some random data. And then I'm gonna run a capability analysis. Okay, so if this is too advanced to you, just know that the best way to measure, to assess a process is by far via capability indexes, okay? And one of the most famous capability indexes is PPK. Another one is CPK, right? Let me change one thing here in the X. Let me do 15. And here, 5. So one thing that I want to explore with you guys is, type here in our chat window. Hello Joanne, how are you? Hello Motze. One thing that I want to explore is, see that we have our histogram. It's a histogram. All these blue bars here, they form one of the most famous graphical tools in quality management in general, that is histogram. Based on histogram, we do project our probability distribution. And by the way, CPK, PPK, or let me include here Z-bench. Let me include here Z-bench. Yeah, they are calculated based on our probability distribution, not based on our histogram. I'll say that again. Type yes if you understand that, okay? Type yes if you understand that. So when I say that this process is 1.61 sigma, this is based on the probability distribution, in this case, the normal probability distribution, not on the histogram. I mean, obviously, the probability distribution is connected to the histogram. So, let's say indirectly, sigma level, PPK, CPK, they are connected to the histogram. But it's like histogram, probability distribution, and then capability indexes. That's the sequence. And that's why it is so important to find the right probability distribution. We cannot simply take for granted that all processes behave according to a normal probability distribution. Right? Beautiful. So, what I want to explore, and I'll make it even simpler. What I want to explore here is I have just changed here to percentage, yeah, to percentage. I want to check if you guys are comfortable with the expected performance. And here I just want to explore the overall. Okay, let's keep it as simple as possible. So do you guys understand that Minitab is projecting, is predicting that we'll have 2.55% of defective items below lower spec limit? Do you guys understand that? Yeah, Minitab is projecting. Minitab is expecting. We are expecting. Yeah? We are predicting that our process, because see, this is a sample. This is a sample. This is a sample. What about the population? Population, we can infer, we can expect that 2.55% of our items here will be defective items, more specifically operating below lower spec limit. Yeah? And also 2.77 above upper spec limit. Yeah? So if we are on the same page, type here yes. If we are on the same page, if you understand that. Because now, yeah, my idea with you guys is to find, these numbers, or more specifically, I want to find this number here, 5.33%. I want to try to connect 5.33%. I want to connect 5.33%, and let me increase here the that's okay, 5.33% to a Z-bench, a sigma level of 1.61. Okay, that's what I want to do, to connect 5.33% of defective items to 1.61. Yeah, and let's see why Z. YZ. Yeah, so let's do that, because if you guys understand that, it will be super simple to understand what is exactly Six Sigma and what's the percentage of defective items that we expect on a Six Sigma process. Okay, what is the percentage of defective items that we expect on a Six Sigma process? Yeah, so let's go there. Let's go there. One of the most famous probability distributions in this planet is the Z distribution. Or let me go there. Let me go there. Let's go little by little. Let's go little by little. Remember that if I come here in graph, probability distribution, plot, I can easily find, for example, many different types of distributions, and I can view probabilities. I can view probabilities. So I can come here, for example, I want to see these two here. So again, below lower respect limit and above upper respect limit, but you guys will see that I will add up everything and put in one side only. Okay, so okay, if I consider a normal probability distribution with mean equals to 0 and standard deviation 1, yeah, we call this the standard normal probability distribution. Standard normal probability distribution. And it is very useful to observe probabilities. Very useful. Yeah. And then I can do, for example, I can ask Minitab to plot for me the area when I have, for example, -1 and +2. -1 and +2. So from -1, sigma, standard deviation. So 1 standard deviation to the left side, 2 standard deviation to the right side, I will have an area under the curve. So it's an accumulated probability of 81%, 81.86%. Yeah, 0.8186. It's pretty much 81.86%. So in practical terms, what is this? If I took a sample from a certain process, and then I found the normal probability distribution associated to that process, I can argue that from 1 standard deviation below the mean and 2 standard deviations above the mean, I can argue that 81.86% of your next parts, of your next products or services will, 81.86% will fall between -1 and +2 standard deviations. And if you know the mean and the standard deviation, you can have the absolute values. So it's very helpful to do this kind of analysis, because remember, the total area under the curve is 1. 1 is 100%. So we can do all sorts of, what if analysis. We can do all sorts of projections, yeah, using this resource. It is very helpful, very much helpful. Now connecting to our context here, again, we want to connect, yeah, we want to connect the sigma level and the percentage of defective items, and understand and see that in our probability distribution. So once again, take a look here. We want to connect 1.61 to 5.33%. Yeah, and for that I will need two very important information. Okay, two very important information. Remember that I do have a sample mean and I do have a standard deviation overall. Yes, we do have that. But remember that we are operating right now on the standard normal probability distribution. So, what do you think will happen if I simply, right now, if I simply come here and indicate, for example, 1.61. So see, that's interesting. 1.61. Let's take a look. Yeah, let's take a look. So what is going on here? What is going on here? So remember, once again, we are trying to find a 5.33%. Can you guys see? And remember, guys, remember that we have like a different number of decimal places here. Yeah, so there is some rounding error. Some rounding error. So please expect some problems on the second, sometimes even on the first decimal place. Yeah. But what is 0.0537? What is that? What is that? This is the total projected expected percentage of defective items. Simple like that. Simple like that. So after you run your capability analysis, if you want to understand how your sigma level is connected to the percentage of defective items, it is one of the simplest things ever to do. You just need to plot a standard normal probability distribution, place just one area, okay, Vindra and everybody. Even knowing that here I have problems below lower spec limit and above upper spec limit, remember that sigma level considers both areas, and then we add up to just one side. We concentrate in just one side of the probability distribution, and that's it. That's it. Very simple. Very simple. So if I have a process that is 1.6 sigma, I do expect to have 5.33% of defective items. Simple like that. Simple like that. According to the industry standard, this is not good. Like 5.3 is too much. If I have a process that is 2 sigma, I do expect to have, take a look, 2.275. Yeah. And there is a conversation about like the two sides, you know? There is a conversation about the two sides. Another area here, but I want to keep it as simple as possible. And then, very interesting, what happens if I have, for example, so let me just try to connect here. And let me change the specification limits. Normal. Let's do 12.5. Let's make 12.9. 10.2. I want to go as close as possible to 2. Too much. 9. Yeah. So see that in this case, a sigma level around 2 would give me around 2% of defective items. Yeah, of defective items. And then I want to keep going, to keep moving. And I want to see what happens if we have 3 sigma. Yeah? What happens if we have z equal to 3 sigma? Then we have 1 decimal place. Can you guys see? We have 1, 2, so 0.135. What happens if we have a 4 sigma? And what happens if we have 4.5 sigma? And you guys will understand why the 4.5 sigma. So what is 3.4, right? 3.39, it's 3.4 times 10 power minus 6. So which number is that? 10 power minus 6. So I have 6 zeros. I have 0.00000034. This is the famous 3.4. Now it's not percentage. It's not per 100. Now it's per million. Have you guys heard about the 3.4 ppm? Yes or not? Type here for me. Have you guys heard about? Yeah, it's 3.4. It's the rounding error, Vindra. Yeah. So 3.39, pretty much 3.4, right? Yeah. So 3.4 defective items out of 1 million. Or 3.4 defects per million opportunity. Yeah, let's suppose I have 1 million opportunities of having a certain defect, you know, and I had only 3.4. And we have a problem here. Because 3.4 isn't 3.4 ppm associated to 6 sigma. Yeah? So I don't have 6 sigma here. I have 4.5. I have 4.5. I don't have 6 sigma here. So what's going on? What's going on? Unfortunately, the 3.4 ppm became very popular, very famous, very famous. And unfortunately, it does consider the 1.5 sigma shift. Because some literature about Lean Six Sigma suggests that processes will drift over time from 1.4 to 1.6 sigma. And then some authors decided to place as a strong recommendation, and many authors as something mandatory, to always add up 1.5 sigma to the calculated sigma level. Meaning, when we run a capability analysis, in fact, sigma level is the long-term performance. I would say 4.5, in fact, it's the drifted process. It's the process from 30 days from now, 1 year from now. Today, if you want to know process performance today, you should adapt 1.5, and then some authors call this sigma capacity. I don't like this approach, and I do not recommend this approach to my students. But the problem is 3.4 ppm is it is brutally popular, brutally famous in the Six Sigma world. Many people use, if your process is 6 Sigma, you have only 3.4 problems per million, defects per million opportunity or defective items. But in fact, if your process is truly 6 Sigma, you should place here number 6. Yeah? And then see, 6 Sigma, we would have a different area here. It is pretty much 9.8 times 10 power minus 10. And then we would be talking about parts per billion. Parts per B as in ball. Parts per billion. The true Six Sigma process, Once again, my recommendation is just run your capability analysis, then you take the overall Z-bench, and that's it. On measure phase, same thing on improve phase. That's it. And if you want to understand how sigma level is associated to a certain percentage of projected defective items or defects per million opportunity, you can run this very simple analysis. Yeah? And when you have like problems on just one side of the probability distribution, let's suppose you have only a projection of defective items below lower spec limit. You don't have any problems above upper spec limit because you don't have an upper spec limit. If you have this kind of situation, take a look, 2.05. You can just come here, graph, .05, and then there is a projection of 2.018, and once again remember that we have a rounding error here because of the number of decimal places. Okay, but it's very easy, very simple to observe. Yeah, Vindra, I think Vindra, first, thank you for your question. It's an amazing question. Vindra sent by email. I think Alexandre explored this yesterday in your exclusive, because all green belts and black belts, they have an exclusive Q&A session every Monday with another professor that works for MF OPEX as well, Alexandre. It's an amazing professor. He knows a lot. I believe Alexandre covered this yesterday, but please let me know if that was helpful, okay? Let me know. Jessica, dear professor, in the automotive industry, what's the accepted ppm and sigma level, please? In the automotive sector, the expected sigma level is 4, at least 4, yeah? Because normally 4 is associated to 1.33 CPK of at least equal to 1.33 CPK and PPK. Some automotive companies, they already talk about 1.67, that is 5 sigma. So minimum 4 sigma. Minimum 4 sigma. And then it's definitely not like percentage. It's ppm. It's ppm. Yeah. My pleasure, Vindra. My pleasure. Question from Alimes. Has some companies reached Six Sigma quality? It's very difficult, Ali. It is very difficult. And remember that sigma level should be calculated per CTQ, per variable. So I can be Six Sigma, for example, in automotive sector. I had a chance to work 7 years for Delphi Automotive Systems. We produced wiring harness, like the system of distribution of signals and power in the cars. And then we have a multi-wired cable, copper cable. We have terminals and connectors. In order to attach the metal terminals to the multi-wired cable, copper cable, you have a process called crimping. Yeah, it's pretty much a deformation of the wings of the metal terminal, boom, on the multi-wired cable. But you cannot push too hard, otherwise you will cut the copper wires, but it cannot be too loose, otherwise you can have problems in terms of performance, conductivity. So it's pretty tricky, It's a beautiful process. Crimping is a beautiful process. So imagine a connection, a crimping process for airbag. We cannot have like conductivity problems with an airbag connection, right? When there is an accident, boom, it must work. It must work. I had a chance to work directly in these processes. There was a validation laboratory for all sorts of crimping, all sorts, like huge terminals, smaller terminals, dome lamp, do airbag, and obviously they are all connected to the battery, right? And then there is an electrical communication. Beautiful. These processes, the height of the of the of the crimped connector, this CTQ was like 30 sigma. CPK was around 10. Meaning the probability of having a problem, of operating outside specs, in terms of the height of the connector after crimping. So see, it's very specific. For this parameter, that is very critical. It's a CTQ, critical to quality. This parameter was 30 sigma. So I know that many times we listen here and there, oh, there is a company that is 6 sigma. In order to claim that a company is 6 sigma, I understand that like all processes should be operating, at least all processes should be operating on a sigma level that is at least 6. And in my humble opinion, there is no company in this planet that operates like that. There is no 6 sigma company. There is no 6 sigma company. Mainly because for some CTQs, maybe you don't need 6 sigma. I don't know if you guys can see, but the position of the label is not perfect here. It is not perfect. There is a misalignment here, a small misalignment. So I can argue that this is a defect. Or if I measure that and plot and run a capability analysis in terms of alignment, I don't know, I think it will be 0.5 sigma, 1 sigma. And that's okay. That's okay. But what about the cleanness? The cleanness of the water. The number of things that we don't want to see in the water. In terms of quality of the water. Oh, I hope it is at least 4 sigma. But if the label is a little bit, I don't know, blurry, or if it's not perfectly aligned, so for some CTQs, 4 is amazing. 4 sigma is amazing. So a company can argue that for a list of parameters, they are 6 sigma. Because not even in automotive sector, you will find many processes that operate at the 6 sigma level or above in automotive. Many processes, many. For example, crimping process for airbag connections, or crimping processes in general. I would say it's easy to find CPK equal greater than 2. It's easy. There is here in Brazil a company named Embraer. So they make airplanes, you know. Aerospace in this industry, it's funny. Sometimes you don't find Six Sigma processes, but the vast majority of the critical processes, you have like duplications, you know. So you have a process that is, for example, 5 sigma, but if it fails, there is another process that operates immediately at the 5 sigma level. And if it fails, then you have another one that operates at a 5 sigma level, you know. And then that drastically reduces the final probability, you know. Yes, duplicity. um, yeah, so this is very helpful too. The only problem is that it increases the cost very much, right? But we all know that in automotive sector, if we think in terms of FMEA, the severity of the failure modes tend to be lower than the severity of the failure modes in aerospace. So we need to compensate that with frequency, occurrence, and also detectability. We need to be in aerospace much we need to detect much faster, and always we need to fight for a lower occurrence of the failure mode itself. Yeah, wonderful. How helpful is that? Type here for me. Is it helpful? Professor, I have an interview on continuous improvement and operational excellence. What would you suggest to me to know before my interview? Cedric, the very first thing before preparing for the interview itself, study about the company. If you have information about the person that will be talking about, will be interviewed, try to know a little bit about this person. Mainly to dribble things that you should not talk about. Yeah. This is more important than we think. Because we are humans after all, right? So if you can have the information of the person that will be interviewing you, please try to learn as much as possible about this person, about your interviewer. Yeah. Again, not to kind of speak things that the person, you know, like let's suppose I am interviewing you, and then you start talking about guitar, and then you say that you love guitar even knowing that you don't love guitar, that music's the most important, then it's too artificial, you know. But knowing that Marcelo likes guitar, that he comes from a family of musicians, if you can here and there maybe mention about music, just mention about music, or mainly do not say things like, no, I don't like arts, I think arts is BS, you know. You would never say that, because believe me, we are humans after all. We try to be as neutral as possible, but we are not. There are different types of connections, you know, at the human level. So That's one thing. The third thing is communicate objectively. Communicate objectively, if possible, straight to the point, but without being aggressive. So don't be passive nor aggressive. Yeah, be assertive. And in terms of topics, then I would strongly recommend you going high level first. Only if they ask you the difference between CPK and PPK, then you go. Because if you start all of a sudden talking about the difference between CPK and PPK, it will sound as show off. That you wanna show off that you are the best, that you know everything, you know. So normally, self-confidence with humility works very well. This combination works very well. Self-confidence without sounding arrogant. You need to guarantee that you are expressing your strengths, your capabilities, but that at the same time you know that you have things to improve, you know, that you know about your limitations. Yeah. And if they ask you, tell me about a weakness, please don't say, I am perfectionist. This is the top one cause of rejection in job interviews. You know, don't say that. Don't say that. Tell me something that you need to improve. Oh, I am perfectionist. I like perfection. This is artificial. This is strange. This is fake. So normally, they want to know your strengths, but at the same time, they like mainly HR people. If you have a first interview with HR person, you definitely want to talk about vulnerabilities. Definitely talk about vulnerabilities with the leaders, the managers, the directors. It depends, because you don't wanna bleed on a shark tank. Do you guys know this expression? Never bleed on a shark tank. So then it depends. It depends. But even for sharks, you wanna show, you know, self-confidence. You need to be as assertive as possible, you know, but at the same time, you need to be very careful for not sounding arrogant. And I wish you all the best, Cedric. Okay? All the best. All the best. I feel confident that you'll do amazingly in this job interview. Professor, I wanted to know if it is possible for the green belt certificate expire. No, our certificates do not expire. Okay? Professor, I would like to know how to use SPC in ongoing operation. So SPC, if you want to implement an SPC, I would strongly recommend you to hire an SPC expert, you know, because it involves very likely you will be spending some amount of money yourself, because very likely you'll be acquiring some sensors, different sensors. But the general rule of thumb is you start with the highest frequency possible. Yeah, and then you focus on finding what we call the rational subgroups, meaning the variation is concentrated on the mean chart, yeah, on the on the on the dispersion chart, you don't want to see special causes. Yeah, and less is more. Less is more. For SPC, be very careful with collinearity. Collinearity. Sometimes you are measuring the temperature of the oven, the temperature outside the oven, the temperature in the oven's door, but all of them are giving you very similar, behavior. So be careful on, wasting money and energy on, over monitoring. Don't over monitor. Don't over monitor. Because, see, frequency, if you are taking 10 parts per hour, and then now you know that you just need to take 10 parts every other hour, then it's easy to change sampling frequency. But CTQ, no. CTQ, you need to buy, you need to invest money on sensors, for example, So if you decide later on that you did not need like to measure 4 CTQs, temperature inside the oven, outside the oven, the oven's door, the top of the oven, and you just needed to measure inside the oven, you already spent money on other sensors, So, yeah, talk to the experts to create the map of CTQs. And if you want to implement an ongoing SPC system, you definitely need to have like a consultant for 3 months, 6 months. So he or she will help you to find the better variables to measure, the best frequency, sampling frequency. Okay. Wonderful. Hello, Professor and the crew. I'm struggling with connection. Oh, no problem. I always leave the session here, okay? Recorded session. Yes, Vindra, that's the right word. Redundancy of systems. Thank you so very much. Thank you so very much. Yeah? Very insightful and helpful. Thank you. Thank you. Professor, is normal distribution, Z distribution, Z and Z bench the same things? Vindra, so see, Z distribution is one type of normal distribution. Z distribution is a normal distribution where mean is always 0 and standard deviation is always 1. Normal probability distribution, I can have anything. The mean can be 10, the mean can be 15, the mean can be 20, depending on what I am measuring. Yeah? But the Z distribution is a normal distribution, but the mean is always 0 and standard deviation is always 1. So it's easy to visualize things as we saw. That's why we call the standard normal probability distribution. Okay? Z and Z bench are the same things. So see, Z and Z bench, it is sigma level. This is sigma level. And sigma level is based on the area, right now we know, concentrated in just one side. So when we shift to the Z world, we don't have both sides. Normally, for sigma level, we don't have both sides. We concentrate everything in one side. Guys, if you are new to Lean Six Sigma, this is an advanced conversation. This is a green/black belt conversation. So if you are not following, if you are new, if you are a white belt, for example, don't desperate. This is an advanced, this is naturally a not so easy conversation. It's not rocket science, but it's not super trivial. It is not, okay? And again, we approach this very deeply in our green belt and in our black belt trainings. Professor, I like to apply Lean Six Sigma in our IT team technical department, but I don't know where to start. Royce, please start with listing, prepare a list of problems that you don't know the solution. Problems that you don't know the solution. You know, chronic problems, structural problems. Professor, when I take my green belt exam and pass, can I take it again to have a better pass mark? Yes, you can, David. You can. Just remember with love. What I'll say here, it's with love, okay? You can, David. Do that. Just remember that one of the most critical types of waste is overprocessing. Just consult your heart if you are not doing this too much, you know? Yeah. Overprocessing is when we are trying to reach a certain level of quality that is disproportional to the value. I want to have my screen as clean as possible. I want to have this screen here see, it's dirty. It's dirty. I want to have it as clean as possible, you know? So one thing is, 5 seconds or 10 seconds, you know? 10 seconds. That's it. Much better, right? Much better. Is it perfect? Can it be improved? Can I improve the cleanness of the... Yes, I can. I can spend like 1 hour here. I can spend 2 hours here. But the amount of value, and what is value? Value is the quality of the reading. So if I spend 2 hours, will I have an improvement in terms of value that is proportional to the money, to the time, to the energy that I'm spending? I don't think so. Overprocessing, one of the 8 types of waste, okay? Guys, I hope this time flew as fast as it flew for me. I don't understand when I look at the clock and I see that 1 hour has passed, you know? This is crazy. Today we had more of a technical conversation, once again, but very important. Thank you so very much. I cannot guarantee that every week I'll be here with you, but I will do all my best to touch base openly to all my students, white belt, yellow, green, black, master black, or even if you are not my student yet. Yeah, based on the huge number of requests, I think we have never received the number that we received of requests for running another white belt. We will be running next week. So on March 13th, 14th, and 15th, I'll be running a white belt class, and then on March 15th, we'll be opening up for yellow plus green, the registration process for yellow plus green belt, okay? So stay tuned in case you are not a white belt, or if you are a white belt and want to become a certified yellow and green belt, there is a good opportunity in March, and then very likely after that in August, okay? Thank you so very much. Thank you, Vindra. Thank you for your question. Thank you, Ali. I'll talk to you guys. Have an amazing rest of week. Bye-bye.